Good morning, first years. Now, I apologise. I ended up leaving out the last question on your exam papers. I had an issue with my computer and my printer, and for some reason, the last page disappeared. So I had most of them corrected by the time I realised the issue. So I figured it was better to just leave it out for the moment. But I do want to go through the solutions of it, and you might let me know if there's something that you don't understand and you want to ask a question about. So let's quickly go through this. And you might take a look at your own tests and make sure that you got the right answers. We won't be changing the results, but take a look through them all the same. So the first question was to write each of the numbers correct to the nearest 10. So to the nearest 10, this would be 120. This one I'm going to be rounding up because of the 5 there, so we would round that to 200. This one would round to 500. These ones to 3 decimal places. So the number after the third is a 5, which means I round up. And I've got 105.556. This is already to 3 decimal places, so I don't change anything. 2.173. And here the number after the line is less than 5, so I make no change. And that's 0.026 to 3 decimal places. Now there was a test on significant figures. So we're just looking at the first 2 non-zero numbers and the number after that. That is less than 5, which means I round down, and I've got 2900 to 2 significant figures. First 2 figures, and the number afterwards is bigger than 5, so I round up 160. 2 significant figures. I ignore any zeros at the start. These are my first 2 significant figures, and that's greater than 5, so I round up 0.034. So you might check those answers, and if there's something you don't understand or if you've answered it differently, just let me know. Part D. Karen went to a shop to buy 5 magazines. She had €10 to spend, and she made an estimate of the total cost by correcting the price of each magazine to the next highest euro. Okay, so she's not rounding in the normal way, she's rounding up regardless. So this will round to 2, this will round to 2, this will round to 4, this will round to 2 even though it shouldn't, and 99 cents would round to 1. 2, 4, 8, 10, 11. So her estimate is €11. Based on the estimate, would she think she has enough money? No, because 11 is bigger than 10. They didn't ask us for a reason, but I'm explaining to you. Work out the exact cost of the magazines. Now, I don't need you to write it down. It will be okay to just use your calculator for this. But if in doubt, because there was a lot of questions that people answered, and I did need to see the working out, and people didn't show it. So if you're not sure, anything you type into your calculator, just write it down on the page as well. It doesn't take that long. And that way you can get full marks. And it also makes it clearer for the person correcting it what you've done and what you're trying to do. So €9.92. €9.92. So she would have had enough money. What do we think is a better method for estimating the cost of the magazines? Well, rather than rounding up regardless, what would have happened if she rounded to the nearest euro properly? So rounding to the nearest euro, not just rounding up. And then she would have had 2 plus 2 plus 4 plus 1 plus 1. And that would have given her 10. So the reason it's more accurate. Now, if you wrote a reason and you're not sure whether it was right or wrong, you can just drop me a message here in Google Classroom and I'll answer that. So that was the final page of your test. I'm going to keep going with this same video and move right on to a few further examples with calculating probability. Today, I mostly want you to do some practice with tree diagrams during your class time, and there'll be, then take down these notes on calculating probability, and then there'll be a little bit more homework as well. So just a very quick few examples of calculating probability. A reminder to ourselves that the probability of an event is the number of matching outcomes divided by the total number of outcomes. So I just wanted us to have a few more examples of this. It's not really anything new, but it's just practicing with the concepts. So this will be our second example under calculating probability. And we want to calculate the probability of drawing a red card from a standard deck of cards. Now, what do we need to know? Well, first of all, we need to know the total number of cards in a deck, and that is 52 cards. And how many of those are red? So the number of red cards, well, if you turn back to the page in your book where we looked at the deck of cards, you can see that all of the diamonds and all of the hearts were red. 13 diamonds, 13 hearts, 26 red cards. And so the probability of drawing a red card from a standard deck of cards is the number of matching outcomes, all the red cards, divided by the total number of cards. And that simplifies when you can put it into your calculator, or maybe you can do it in your head, to 1/2. Exactly half of the cards are red. Let's do another example very quickly. Slightly different. So a bag contains 3 red marbles, 4 green marbles, and 2 blue marbles. Calculate the probability that a random marble drawn from the bag is, I'm going to have 2 different questions here. What's the probability that the random marble is green? And what's the probability that the random marble is not red? Sorry, I went off the screen there. Okay, so remind ourselves again, the probability of something happening is the number of matching outcomes divided by the total number of outcomes. So the very first bit of calculation we need to do here is calculate the total number of marbles in the bag, because that's going to be my bottom number in my probability. So the total number of marbles in the bag is 3 red, 4 green, and 2 blue. And I add those up, I have 9. 3 plus 4 is 7, plus 2 is 9. 9 marbles in total. So for part 1, the probability of pulling out a green marble, well, is how many green marbles are there? The question tells us there are 4 green marbles. So that's 4 divided by the total, 4/9. Now that question doesn't simplify, or that fraction doesn't simplify. So 4/9 is our answer. The 4/9 probability of pulling out a green marble. What's the probability that we don't pull out a red marble? Not a red marble. Well, again, it's going to be out of 9 because that's my total. Then how many outcomes match not being red? 3 red, 4 green, and 2 blue. So the green and the blue ones are not red. 6 out of 9. You wouldn't leave our answer like that. You would be expected to simplify that to, I apologise, 2/3. 2/3. Let me write that again. 2/3. And those are our answers. Okay, so that's what we need to do when we're calculating probability. Now, today in class, I've uploaded some classwork for you. I suppose everything is kind of homework nowadays, but I want you to spend some time with tree diagrams on page 121, questions 5, part A, question 7, and question 8, part B. And that will be up in Google Classroom. And then for homework, I want you to do page 127 to 128, questions 4, 5, and 6. So these are probability, and these are tree diagrams. Tree diagrams. And that information will be up in Google Classroom as well. Okay, thank you very much, first years. I'll talk to you tomorrow, and you can let me know if you have any questions or if there's something you don't understand. Goodbye.